Welcome to 6.1, and this is trigonometry. So we're going to talk about measurements around circles and triangles for the whole semester here. So lots of stuff on this page. Understanding what a terminal side and an initial side. Initial side is always what we look at where we're starting. A lot of times this is the x-axis, and that's what it looks like as we're going that direction. And you can see the circle that they did there. They went around a whole circle, and then they came to line 2. And then down here on the second one, they went around the whole circle backwards one whole time, and then to that same line. So these are the same pictures. One goes up to the left all the way around, and then the other one goes down to the left and all the way around. So we always go up to the left. That's why this is called quadrant 1, quadrant 2, quadrant 3, and quadrant 4. That's the direction we always go. And then whatever degrees that is a positive degree. And if you're going this direction, this is a negative degree. Okay? All right. And then if you look at this definition of radian measurement, it takes the radius and places it around the circle. And how many radii are all the way around? Well, this is where we get the term radian measurement. 1 radian is the measure of the central angle of a circle subtended an arc equal in length to the radius of the circle. What that means is, how many radii go all the way around the circle? Well, think about it. The circumference of a circle is 2 pi r. Well, 2 times the radius is your diameter, right? All right, so what is 1 pi? So if our radius, 1 pi times the radius is going to be halfway around the circle. Okay, so a full circle, if the radius is 1 unit, so 2 times 1 is 2. So a full circle is 2 pi based on radian measurement being 1. So all the way around is 2 pi, which means 6.28. So all the way around is 6.28. That's 2 pi. Well, halfway around is 3.14. Okay? Halfway around. 3.14. So we get our radian measurement by how many radii go around something. And we can convert degrees into radians, and also pi values. So there's 3 different measurements. We have degrees, pi's, and radians. And they all mean the same thing. Just like you can have 12 inches in a foot. Those mean the same thing. We have different units of measure. Okay, and then we have a relationship between degrees and radians. How do you convert radians and degrees? Well, here's the easy way to do it. If you want radians, then put the radian unit on top and multiply by it. So if I want to convert 60 degrees to radians, I need to have the radians on top and the degree on the bottom. Radians is in terms of pi, and degrees is just degrees. And then we multiply across and see what we get. If I want degrees, then degrees needs to be on top and radians on the bottom. So if I said, well, how much is pi over 3 in terms of degrees? Well, I would multiply that together. Okay, the pi's would cancel out and I get 60. Oh, look at that, 60 degrees is pi over 3. And if you were to multiply that whole thing together, you'd get pi over 3. Okay, now we go down to the next thing. Circle, formula for the length of a circular arc. So the length around a circle, S, is your radius times theta. But here's the thing. Theta has to be put into radian measurement. Okay, so theta times pi over 180. All right. And then we have the area of a circle sector. I'm sorry, let's go back here. The circular arc. Notice it says the length of the arc has to be in radian measurement. if they give you theta in terms of pi, you don't have to multiply by pi over 180. But usually they're giving you theta in terms of a degree. So you have to change it to radian measurement. Okay, now the formula of the area of a circular sector. So what are they talking about there? A sector of a circle. So like if I wanted the area of that sector, well, it's 1/2 r squared times theta. And again, theta has to be multiplied by pi over 180 to make it radian if it hasn't been in radian anyway. All right, so that's enough of the instruction. Let's get at our assignment. If the given angle is in standard position meaning right here, the x-axis positive, find two positive coterminal angles and two negative coterminal angles. All right, so first of all, where is 120 degrees? So 180 is all the way to the other side. So let's go up to 90, and then 120 is 30 more. So right here is 120 degrees. All right. So now we need two more positive, meaning we got to go this direction to have positive coterminal angles. That means where is the angle that matches that position? So we go all the way around 360, okay, and 120 more. So 360 and 120 is 480, and we go around 360 again. That gives us 840. So there's two positive coterminal angles. Now, two negative, that means we're going this direction. So we can just go all the way around to that position. Not all the way around, just to that. So 180 gets us to this position. And then if this is 120, that means this is 60. So 180 and 60 is 240. So negative 240 degrees. And then we go from here around another 360 degrees more than 240. So add that together. That's 500, be 600 degrees. All right, so there's your two possibilities. Now, letter B, 135. 135 is right here. So there's your 135. And again, what we'll do is we'll go all the way around 360 plus 135. That's 495. And add 360 to go around again to get to the same position. So 360 and 495 is 7, be 855 degrees. Now negative, we're going this direction. So let's start here and go to there. So 180 plus whatever this amount is, that would be 45 degrees. 180 and 45 is 225, and it's negative. Don't forget to put the negative sign on it. And now add another 360 degrees to that same thing. So 360 and 225 is 585. Negative 585 will get you in those same positions. All right, now where are we? Negative 30 degrees is going to be right here. So there's negative 30. Now we need a positive value. So from here to there would be all the way to 180 plus 90 is 270. And how much is this part right here? That would be 60. So 270 and 60 is 330 degrees. All right, and then go around another 360 degrees to that same position. So 360 and 330 is 690 degrees. Now let's go backwards. So now we have to go all the way around 360, and then 30 more would be 390 degrees. Don't forget your negative. And then another 360 degrees again. So add 360 to 390 is 750. Okay, so now we got to figure this out. 620 degrees. Well, all the way around is 360. And if you go all the way around again, that's 720. So that's 100 degrees too many. So let's do 360 and 90 is 450 and 90 is 540. 540 and 90 gives us 630. That's too many. So 10 degrees too many. So we must be right here at 620 degrees. All right, so now let's do just positive to that point. Well, 180 And then we have to figure that's 10 degrees less than 90. That's just 10 degrees there. So this little piece here is 80. So 180 and 80 is 260. So positive 260. And then another 360 degrees around again. Add that, that's 5, that's 620 degrees, which is, we already have that, so we can't use that one. So we got to add another 360 to that. And that gets us to 980. Okay, so now we got to go negative. So there's 90 plus that 10 more. So that's negative 100 degrees. And now you have to do another 360 from that, so negative 460 degrees would get you there. Okay, now how do we do 5 pi over 6? Remember, all the way around is 2 pi. So halfway around is pi, or 180 degrees. Those two are the same thing. So this is 2 pi all the way around. So let's do 5 pi over 6. Well, what if pi is 180? What's 180 over 6? 180 divided by 6 is 30. 30 times 5 is 150 degrees. So 150 degrees is right there. 30 degrees shy of 180 degrees. So if this is 5 pi over 6, we're going to keep our answers in terms of pi over 6. So we're going to go all the way around again. So add 360 to 5 pi over 6. Except in terms of pi, 360 is 2 pi. So 2 pi plus 5 pi over 6, we got to get a common denominator. So we multiply by 6, that's 12, and we get 17 pi, oh my goodness, 17 pi over 6. Now add another 2 pi to that, and again, get a common denominator, and you get 29 pi over 6. So there's your two positive values. Now let's do negative. So there is 1 pi and 5 pi over 6. To make that equal to pi over 6, you would add a pi over 6. 5 pi and 1 pi makes 6 pi over 6. So this little distance right here is just pi over 6. So we went negative pi, and they're adding a pi over 6. So pi and pi over 6. Get a common denominator. 6 pi over 6 plus pi over 6 is 7 pi over 6, except it's negative. We're going left, or down and left. It's negative 7 pi over 6. Add another negative pi over 1, or 2 pi over 1, okay? So get a common denominator. Times 6 be negative 12, and negative 7 is negative 19 pi over 6. So there's your two negative pi values. All right, negative pi over 4. Let's do negative in red. Halfway, pi over 4 is 180 over 4, which is 45 degrees. So that puts you at this little pi over 4 stem. All the pi over 4s are in the middle ones. All right, so this is negative pi over 4. So let's do positive all the way around to there. So we get to 180, that's 1 pi. And 90 would be half of pi. So 1 and 1/2 is 3/2 pi. And then plus another pi over 4, because the pi over 4 is halfway in between. So what we have is 3 pi over 2 plus pi over 4. Get a common denominator. And you get 7 pi over 4. Okay, now add another 2 pi, because we're going to go around again, all the way around. So add 2 pi. 2 pi over 1, common denominator is 4, so that's 8 pi over 4. And add those together, you get 15 pi over 4. So there's your two positives. Now negatives. So we go all the way around. That's 2 pi plus a pi over 4. So 2 pi plus pi over 4. Get a common denominator. 8 pi and 1 pi is 9 pi over 4. And again, that's negative. And go around another 2 pi, another negative 2 pi. Common denominator, negative 8. And negative 9 is negative 17 pi over 4. And there's your other negative coterminal angle. Okay, so now we gotta find complementary. Complementary means that it's 90 degrees. The two angles add up to 90 degrees. So you have theta, which is 12 degrees, 37 minutes, and 24 seconds. Well, 90 degrees would be 89 degrees, 59 minutes, and 60 seconds. 60 seconds would be 1 minute, which would change the 59 to 60, and that 60 minutes would change the degree another degree up. So 90 degrees is the same thing as what I just wrote there. Okay, so if we take this 90 degrees written in terms of minutes and seconds, and we subtract the 12 degrees, 37 minutes, and 24 seconds, we'll get the complementary angle. So this is the part you should need to remember for minutes and seconds. Okay, so 60 minus 24 is 36 seconds, and then 59 minus 37 is 22 minutes, and 89 minus 12 is 77 degrees. So 77 degrees, 22 minutes, and 36 seconds. And if you just have the degrees, then you just take 90 degrees minus the 43.87 degrees. And you just do the normal math. So 8, 9, 9, and 1. 10 minus 7 is 3. 1, 9 minus 3 is 6. 8 minus 4 is 4. So 46 degrees, 46.13 degrees. Okay? So two different ways to find your complementary angle, but you need to remember this part right here. You need to remember that 90 degrees is that. Okay. Now find the angle that is supplementary. Supplementary, well, 180 degrees is the same thing as 179 degrees, 59 minutes, and 60 seconds again. Okay? Same thing as your complementary, except it's from supplementary needs to be 180. So you're subtracting the 125 degrees, the 16 minutes, and the 27 seconds. 60 minus 27 is 33. 33. 33 degrees. And 59 minus 16 be 43. And that's 54 degrees. 43 minutes, 33 seconds. And then, again, supplementary, 180 minus 58.07. So, change everything. 10 minus 7 is 3. 9 minus 0 is 9. 9 minus 8 is 1. 17 minus 5 is 12. All right, so two different ways of looking at it. Minutes and seconds for degrees, or just degrees by themselves. All right, the radian measurement. How do you find radians? Remember, if you want radians, you got to multiply by pi over 180. Okay, because we want radians. Radians is in terms of pi, so 150 times pi over 180. So I can reduce diagonally by 10. The zeros go away. And 15 and 18 are reducible by 3, so that's 5, and that's 6. So 150 degrees is the same thing as 5 pi over 180. 5 pi over 6. Okay? Negative 60 degrees. Okay? So now, negative 60 degrees. Well, what is 60 degrees? All right, so 60 degrees times pi over 180. Divide by 10. And then divide by 3, that gives me 2 and 6. That's 2 pi, and then divide by 2, that's pi over 3. So positive 60 is pi over 3, so negative 60 would be negative pi over 3. 225, again, times pi over 180. Divide both of those by 5, okay, and you get 45, and 5 into 180 is 36. Okay, and then those are both divisible by 9. So that's 5 and 4. So that's 5 pi over 4. Find the exact radian measure of the angle. Okay, again, radian measurement again, 450 times pi over 180. Both are divisible by 10 and then by 9. So this would be 5 pi over 2. Okay, 72 degrees times pi over 180. Both are divisible by 2. Both are divisible by 9 there, so that's 4, and that's 10. Both are divisible by 2. Just keep on going. So this would be 2 pi over 5. Okay, and 100 degrees. Same thing, divide by 10, divide by 2, and that's 5 pi over 9. Now degrees. If you want degrees, then degrees has to be on top, and the pi goes on the bottom. So 2 pi over 3, and when you do that, the pi's reduce out. The radian pi reduces away. And we can reduce diagonally this way, divide by 3, and 2 times 60 is 120. So 2 pi over 3 is 120 degrees. Again, 11 pi over 6 times 180 over pi, because we want degrees. Degrees goes on top. Divide by 6, and 11 times 30 is 330 degrees. 3 pi over 4 times 180 over pi. 4 and 180 reduced by 2, and 2 goes into 90 evenly. So 3 times 45 is 135 degrees. So it's the same thing. Negative 7 pi over 2 times 180 over pi. It's going to give me a negative. 2 reduces into 180 evenly. 7 times 90 is 630. So negative 630 degrees. 7 pi times 180 over pi is 7 times 180. 7 times 100 is 700. 7 times 80 is 560. So that's 1260 degrees. All right. Now, pi over 9. That's going to be 20 degrees. Okay, so let me just show you something real quickly with the 7 pi. That's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. So how many times did we go around? 1, 2, 3. 3 full times around. So 360 times 3. 0, 18, 9, 10. Plus another 180 degrees. 0, 6, 2, 1. Look at that. So it does work. You could just try to figure it out by doing it the long way, but you need to understand that it's easier if you just do the conversion. Okay, theta in terms of degrees, minutes, and seconds to the nearest second. Now we want degrees. Now this isn't in terms of pi. Pi is already factored in. So just a quick lesson here. That's 1 pi, and pi is 3.14. So if theta is 1.57, half of 3.14 is 1.57. Okay, so really that's going to be 90 degrees. So let's show that 1.57 is close to 90 degrees because it's not exact. All right, so how do you find degrees when you have radian measurement? If you have radian, you got to multiply by pi on top. Okay, so we want degrees, so we're going to multiply by 180 over pi. So 1.57 times 180 over pi. So you're going to use your calculator, and this will change it to degrees. 89.954373. Let me check, make sure that's right again. Okay, that's right, and it just keeps going. Now, that would be 89 degrees, 0.954373. Now, how do we get minutes and seconds? Well, you take the decimal here and multiply that by 60. Okay, because that's 0.95, 95% of 60 minutes. That's what that's saying. So take your calculator and take that times 60. And that would be 59 point, okay, so 59 point, let's see, where's it at here? 262,430. Okay. And then, okay, so that's your minutes. Now it's 26% of 60 seconds. So you take that again and multiply it. So we're going to subtract, on the calculator here, I'll subtract off the 57. Oh, I guess it's 57, not 59. 57 minutes. I'll subtract off the 57, and then I'll take that times 60 seconds. All right, so what is my final answer? 89 degrees, 57 minutes, and 15 seconds. And then you obviously have some left over. So if you notice, this is real close to 90 degrees. Okay, so 89 degrees, 57 minutes, and 15 seconds. All right, so you have to just take each decimal times 60. That'll give you the minutes, and then the decimals left over there times 60 give you the seconds. All right, so let's do it again. So 6.3 times 180 over pi. And take your calculator and figure out what that is. Okay, so the reason the pen looks thicker is I have a split screen, which makes it thicker for some reason. I'm using a calculator on the split screen. All right, so 6.3 times 180, and then you divide that by the pi value, and that gives you 360.963. Okay, so think about what that just said, 360 degrees, 6.3. If we look at 1 pi, and then 2 pi would be all the way around. 2 times 3.14 is 6.28. Okay, now that's been rounded. I estimated that. So 6.3 is very close to 360 degrees, which is why that says this right here, okay? 410. Now, so you have 360 degrees, and I'll take the 9.63410 and times that, times 60, and that gives you 57 minutes, sorry. 0.804. So take the 0.804 times 60 to get your seconds, and that's 48 seconds. And there's a decimal of 0.279. Okay. All right. So now our answer is 360 degrees, 57 minutes, 48 seconds. And that's the answer they have in the back of the book. Okay, let's keep going. Let's go a little bit faster now. So we have, we're going to go backwards here. So now we want it, express the angle as a decimal. Okay, so you have 120 degrees. All right, so 120 degrees, but how much is 16 minutes? So understanding that when we wanted minutes, we took the decimals and multiplied by 60. So since we have the minutes and we want the decimal, instead of multiplying by 60, we're going to divide by 60. Now be very careful, because if you had seconds, whatever seconds you had, you wouldn't divide by 60. You're really dividing by 3600. Here's why again. So 360 degrees is 60 minutes. Okay. Well, how many seconds is that? It's not 60 seconds. It'd be 3600 seconds. So those would all be equal at that point. Okay. So we're going to divide the 16 by 60 on a calculator, and then we'll have the decimal. So take that on your calculator, and we'll do 16 divided by 60, and that gives us 0.26 with a 6 repeating. Okay, and that's still in degrees. So now you've converted your minutes into degrees. All right, the next one now, we have the seconds here. So we got 262, and now 15 divided by 60. But then also, you got to take the 31 divided by 3600. Okay, so I'm going to split the screen and go from there. Okay, so the 15 divided by 60 is 1/4. So you have 262.25, and then take 31 divided by 3600, and you get 0.008611. Let me see what that was again. Okay, so the decimals are in the same place, so you got to put all this together. So 262 plus the 0.25 plus the 0.008611. So that's how you should be thinking of it. So the 00 is where the 25 is at. So now we're going to say the answer is 262.258611. That's your degrees in decimal form. So now we're converting all of degrees, the decimals here, into minutes and seconds as well. All right, so you have 63 degrees. So what is 0.169? So 0.169 degrees times 60 minutes. That'll tell you how much of the minutes you have. All right, so 0.169 times 60. That gives me, 0.169 times 60. 10.14. All right, so we have 63 degrees, 10.14 minutes. Now we take the 0.14 and times 60 seconds because we're wanting this to be in second form. So we're going to have 63 degrees, 10 minutes, and how much is 0.14 minutes in terms of seconds? So you're not multiplying by 3600. Okay, you're taking a minute and converting it into seconds. So that's why you're multiplying it by 60. So 0.14 times 60, and that gives you 8.4 seconds. Okay, let's see here. All right, going now this one, we have 310 degrees. So take 0.6215 times 60 to get minutes. Okay, so I'm going to split the screen, which you can't see, but that's what's happening here. So 0.6215 times 60 is equal to, so we have 310 degrees. Now we have 37.29 minutes. I'll take the 0.29 times 60. 0.29 times 60 for seconds. And that'll give us 310 degrees, 37 minutes, and keep missing my decimal, 17.4 seconds. Excellent. All right. Now, circular arc of the given length S subtends the central angle theta on a circle. Okay, so if we look at a circle, let me bring up one of the circle things again here. Let's just draw it, whatever. So you have a circle, and S is what subtends the arc, the length around the curve of the circle. Okay, so theta is 4, which is in radian measurement here. Okay, if it had a degree symbol there, you'd have to convert it to radians, but that's not there. So that's already in radian measurement. So the subtending arc is equal to the radius times theta. Okay, so we just fill everything in that we have. So that's going to be 10 equals, I don't know the radius, times 4. So this is an easy one. 10 divided by 4 is equal to the radius. All right, so the radius is equal to 2.5 centimeters. Okay, so let's go on. 31, find the length of the arc of the colored sector in the figure. So here we have your theta. Theta is equal to degree. So in the formula, theta has to be in radians. All right, now we have 8 for our radius. We want to know the length of this arc here. But theta has to be in terms of radians. So if we want radians, radian measurement goes on top. And now we use our calculator and figure out what this is. And that's 6.28 centimeters. So we're rounding there. Okay, so just think about this. This is 6.28 centimeters. The radius is 8. So if we laid that across, so 8, and it's 45 degrees, right? So another 45 gets us to 90, but the 8 is more than the 6. So let's just use the 6 centimeters here, 6.28. 6.28 is there. That'd be 12.56. And 2 of those would be 25.12. Another one, or just multiply it by 2, get you all the way around there, is 50.24. Okay, now think about this for a second. If the radius is 8 centimeters, we put that, how many radii go all the way around your circle? Well, isn't the circumference of a circle 2 times the radius times pi? All right, well, if the radius is 8, and we have pi is 3.14, 16 times 3 is 48, 16 times 0.4, that's going to get us to that value. So I'm just trying to show you that it is correct, logically speaking, that this is 6.28 centimeters. Okay, that's the answer. So I'm wanting you to also make sure that you understand your answers. That makes you a smarter person, makes math easier. So find the radian and degree measure of the central angle. All right, so S equals R times theta. All right, so 7 equals, the radius is 4. Now it wants theta. Okay, and then it wants the area. So first of all, what are we looking at here? It says the radius is 4. 1, 2, 3, 4. All right, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. There's your circle. The radius is 4. And if the radius is 4, the subtended arc is 7. All right, so it's up here somewhere. We don't know exactly where, but up there somewhere near 90 degrees. So we're going to figure this out. My point is, if you accidentally have something that you're doing, you mishit something on a calculator, and let's say you come up with 190 degrees, which is way over here. You know that's not going to be right, or way over here, 331 degrees. Who knows what you're going to do on your calculator? Knowing about where everything is helps you understand if you're doing it right. Okay, so we're going to divide off the 4. All right, so that's 1 3/4, or 1.75 is theta. Now that's in terms of radian measurement. Okay, so it wants the radian and the degree. So there's our radian. Now how do we convert that to degrees? You take the 7/4, and we want degrees, so degrees goes on top again, and we just multiply out with a calculator. And if you do this in terms of degrees, you get 100.267, I think. Can't remember what it said on the calculator. But it's over 100 degrees, so it's actually over here somewhere. So we were pretty close in estimating about where it would be. Okay? And now we got to find the area of the sector. All right, so here's the area of our sector circle. A equals 1/2 r squared theta. Now, we don't know the area. The radius was 4. We got to square that. And theta. And again, theta has to be in terms of degrees. So this is another reason, in radian measurement. So we found radian measurement to be 1.75. Okay. And radian, think about it, 1.75. So 1 pi on the circle here is 3.14. On every circle, no matter how big the circle is, pi is still 3.14. And at 90 degrees, you're at 1.57. That's the other thing we could have looked at to help us understand we were over 90 degrees. Okay? All right, so now you have everything in place. Let's go ahead and do the calculations. Now, you really don't need a calculator for this one. 4 squared is 16. 16 divided by 2, which is what you have for times 1/2. 16 divided by 2 is 8. 8 times 1.75 is the 7/4. That reduces 14. If you put that in your calculator, it's fine. You should get 14. All right, so the area is 14 square centimeters. Okay, so what are we looking at here? If we look at our picture, really horrible picture, the shaded in area of the sector here for 4 centimeters of a radius is 14 square centimeters. That's what the problem is. Okay, so let's do this again. Let me get a better picture here. Okay, so 50 degrees, this middle line here is 45, so 50 degrees is about right there. All right, find the length of the arc. We want that length. And let's see, if the arc that subtends the given central angle theta on a circle of diameter d, so the diameter is 16, that means the radius is 8. Be very careful. And the arc length and your area, which we have to find. Okay, so both those have to be in radian measurement, and we have it in degrees, so we'll have to convert that. So let's just do that real quickly. Convert to radians, so radians are on top. Divide by 10, so that's 5 pi over 18. So use your calculator to figure out what that is. And that's 0.873. Okay, and excuse me. So that's your radian, 0.873. So let's do the arc length is the radius, 8 times 0.873. Let's set up the area to 1/2. The radius would be 8 squared. And again, times 0.873. Make sure you always get the radian measurement. So let's get a calculator and figure out what those are. Okay, so that is going to be, the arc length is 6.984, and the area is going to be, let's see, 32 times 0.873. 8 squared is 64, divided by 2 is 32. So 32 times 0.873 is 27.936. Okay, so let's take a look at the answer. And there we have it. So 6.98 meters, meters, and the area is b square meters. All right, cool. All right, same type of thing. Circular arc of the length S subtends the central angle theta on a circle. Express the area of the sector determined by theta as a function of theta. Okay, so what it means is it wants to know the area, and you got to solve the area formula for theta. So area equals 1/2 r squared theta. So S is the subtend arc length, so radius times theta. S is 8. So what does theta equal? Or what's the radius equal? Because we need it with just theta in our answer. So that as a function of theta, meaning we only want theta in our formula. That's what that means. All right. So that means you got to get rid of r. So r equals 8 over theta. And now we're going to substitute that into the area formula, 1/2 8 over theta squared, that's r, times theta. So we get 64 over 2 theta squared times theta to the first. So that 1 theta reduces with one of those in the bottom. 64 over 2 is 32, and you still have theta in your denominator. So the area function is now in terms of theta. Express the area of the sector determined by theta as a function of theta, meaning theta has to be the only variable that is on the other side. Okay, just a couple story problems to show you that you can use this stuff. The distance between 2 points, A and B, on Earth is measured along a circle having center C at the center of the Earth and radius equal to the distance from C to the surface. Okay, so let's see here. If the diameter of Earth is approximately 8,000 miles, approximate the distance between A and B. All right, so if the diameter is 8,000, that means the radius is 4,000, which is actually 3,900 something, 3,952, I think. But we'll use 4,000. Approximate the distance between A and B if angle ACB has the indicated measure. So there's 5 problems here. So A, let's say that is 60 degrees. The angle is 60 degrees. So we're wanting the arc length. That's what you're finding. So S equals radius times theta. Theta needs to be in terms of pi. So 60 times pi over 180 is pi over 3. All right, you can use a calculator because you're going to need that anyway. So the arc length is the radius, which is 4,000, times pi over 3 on your calculator. All right, so split screen here. Let's do 4,000 times pi, and then we'll take that number, 12,566, and divide it by 3. So that means that arc length on A is equal to 4,188.8, and that's going to be miles, by the way. Miles. 4,188 miles from A to B. All right, so part B is 45 degrees. So first, got to put it in radians. Divide. We can just figure out what that is. You don't have to simplify it. 45 times pi, and then you divide by 180, and that'll give you the radian measurement. So the arc length is 4,000, again, is your radius, times 0.7854. We'll round that. Leave it as a long number on your calculator and just times it by 4,000. That way you don't have to have the rounded number. And so that arc length is 3,141.6 miles. All right. So now we're going to, well, hold on a second. Move all that up. Now let's do C, D, and E. So part C is 30 degrees. So 30 times pi over 180. That's going to be pi over 6, but we'll just go ahead and do 30 times pi equals, and then divide by 180. And that's 0.523598. Okay, so we're going to take, again, the arc length is 4,000, the radius, times 0.523 something. So leave it as a long number on your calculator, times 4,000. And that's going to be equal to 2,094.4 miles. Okay, 2,094 miles. And then D is 10 degrees. So not a lot of distance here. So first of all, I guess we got to take 10 times pi over 180. Okay, so 10 times pi divided by 180 is 0.1745. So that's 4,000 times that decimal. And you get 698 miles. So 10 degrees is 700 miles, about the distance from Kokomo to middle of Florida. That's kind of rough, but that's about the distance what 10 degrees is. Remember, for half the face of the Earth, that's 1/18th of the distance, which sounds about right. Okay, then E. Let's move all that up again. E is 1 degree. So what is 1 degree? So 1 degree times pi over 180 is just pi over 180. So you take pi divided by 180, and that's 0.017453 times 4,000, and you get 69.8 miles. All right, so 70 miles is 1 degree. It's probably a little bit less than that. And you have 180 of those to go halfway around the globe. So just for instance, if you take that number times 180, To go halfway around the globe, that's 12,566 miles. All right. So there are all your answers. There we go. Okay, 2 more problems. Measuring angles using distance. Okay, so the same as the last problem we just did. If 2 points A and B are 500 miles apart, express angle ACB in radians and degrees. Okay, so you have A, B, and C is the center. It's 500 miles apart. So it wants it in radians and in degrees, whatever theta is here. So we got to figure this out. If you look back at number 39, you can kind of get a rough estimate of how far or what theta is going to be. So it should be less than 10 degrees, which was part D. And let's see, we'll just say, remind us it should be less than 10 degrees, and the radius is 4,000 miles. Okay, so arc length is the radius, 4,000 times theta, and arc length we're saying is 500. Okay, so now we'll find out what theta is, and this will be in radians, so 500 divided by 4,000, and you can reduce it by 100, and theta is 5 over 40, or 1/8. So let's calculate that in decimal. So that is 0.125 radians, rads. Okay, and now how do we convert that? So since we have 1/8 as radians, we're going to multiply it by degrees over radians, because we want degrees now. So in degrees, you're going to take 1 times 180 is 180, and whatever 8 times pi is. So make sure you do that in the group on your calculator. And I get 7.2 degrees, which is less than 10 degrees. That's what we were hoping for. So let's look at the answer. And of course, they put the extra decimal stuff into minutes, and you already know how to do that. All right, last problem. A rectangular window measures 54 inches, okay, by 24, and that's marked in the picture. So 54 by 24. There's a 17-inch wiper blade. Okay, the blade, not the whole stem, just the blade, is 17 inches, and it has a 5-inch arm. All right, so the whole thing is 22 inches. So now we just want, let's just draw this out, what we want here. We don't want this area here. We only want what the blade is hitting, right? The percentage of the window's area that is wiped. So not the full 22 inches here, okay? Not that full 22 inches. But we need to find the whole arc, the whole area, and then we can subtract the area of this arc. All right, so that's 5 inches, and theta is 22. So what are we doing here? The area of the whole arc, all right, the big arc, minus the area of the small arc. That will give us the area that is in yellow there, the part that's being wiped. Okay, so the area is 1/2 r squared theta. Okay, so we're going to do both these at the same time. So this is a great final exam question, where we actually are going to go outside in May, hopefully, and do some of these things. Okay, so area of the bigger arc is 1/2. The radius is 22, not 17. And theta has to be in terms of radian measurement, so 120 degrees. Change it to radians, so radians are on top. Okay, so let's take your calculator and figure that out. Before we do that, let's go ahead and set up the other one. Okay, and then the radius of the small arc, the radius is 5. And you still have 120 degrees, so it's good to know what that number is so we can put it into both of them. And that's 2.094. I rounded it, but if you don't have to round it, don't round it. All right, so let's figure it all out on a calculator and just come up with the answers. So what we're going to do is we're going to figure out this one, the big arc. We're going to subtract what we got for the smaller arc, and then this will be our answer. Okay, let's go ahead and do that on the calculator. All right, so done all the calculations here. Let me move it up. So the final total should be 480.5. So let's see what the answer is. And I forgot, it has to be the percentage. So how do we figure out the percentage of the window? Well, it's just like when you miss a few points on a test. Let's say there's 20 points on a test, or let's make it easier. Let's say it's 100 points on the test and you miss 5. Okay, so that's, you got 95 questions correct out of 100. So to get your percentage, you take 95 divided by 100. All right, so what percentage of the window? Well, we have 480 square inches, okay, that we're wiping. How do we know what percentage that is out of the whole entire window? You take that divided by the area of the window. The area of the window is 54 times 24, length times width. So if you divide that, you're going to get 0.37, which is 37%. Okay, it's not exact, but 37%. Let's see what the answer key says. And there you have 37.1%. So they took it to the 10th position. All right, that's it. Good job.